Good evening, everyone. As we are moving towards the last session of the day, let's dive deep and understand technologies that help you on your modernization journey. Building modern applications doesn't mean choosing one technology, either serverless or container services. Serverless and containers can work together to modernize your applications. Please welcome on stage Mandar Patil, Solution Architect, and Raj Chilakapati, Principal Solution Architect, AWS, to know more. Thank you.
Hear me? Okay. All right, so thanks a lot for showing up for New Delhi Public Sector Summit. And this is the last session for the day. We'll try to make it interesting. Containers and serverless, both these technologies are there for some time now. And then often customers think about, is this either or discussion? Should I go on all in on serverless, or should I start off with containers and move on with serverless? So these are the different kind of journeys that customers walk through. And then today's session, we are going to talk about what are those architectural decision points that we're going to take, whether you should go ahead with containers or which type of containers and what kind of serverless. So my name is Mandar Patil. I am the leader of Solutions Architect team for partners here in India. I am going to run this session with my colleague Raj, who is the Principal Solutions Architect here for AWS in India. All right. So talking about serverless and containers, these are the building blocks of any modern application. So quickly we'll go through what is the modern application architecture, patterns for modernization. We'll talk about technologies and various services available to do so. And then together how, that's a core component of it, that how these two technologies of modernization can work together, what are different architectural patterns that we can think of and can implement of. So this is what we're going to go through, and we're going to be a little bit prescriptive as we go along when I pass on to Raj, that when to select which technology and why. These are the common questions that comes to every architect's mind, and we're trying to address that. We'll end the session with having a bunch of application or architectural patterns which can act as a reference when you go back to your offices and try to stitch your architecture and things like that. So modern applications, right? So let's take a pause and go back to the legacy applications and what does it look like. And you would have all seen this, right? So last 15, 20 years, we have been writing web applications which are customer facing, citizens facing. And essentially there are three building blocks. This is not something new. Let's say we have web server, having a web pages rendering on the mobile applications or on the web servers and things like that. We have application code written in the application layer, and we have a database. If you would think about this, we have to make a choice of a technology for all three layers together. Historically, we'll make a choice. I'm going to write a .NET ASP application. You have to write all the pages and functionality of the .NET application in the .NET. If you're making a choice of Java J2E, you will end up writing JSPs and servlets all the time and make use of frameworks. When you look at the data layer, you have to make a choice that I'm going to go ahead with RDBMS Oracle or MySQL or any of your choice, but all the application functionality will talk to the same database. And we have been knowing this. And this architecture has served us well, because this architecture was pioneer of having e-commerce boom, and a lot of websites were written, and then this was really, really good. Over the period of time, what happened is, when it comes to introducing a new features to this application, we had to have a longer downtime to make an upgrade. Even though there is a small enhancement or bug fix that we want to make, still have to schedule for a downtime. And typically these downtimes are over the weekend, once a month, once a quarter. So imagine a situation wherein you are running two parallel projects, and one project is long running and one project is small running, and then you have to have kind of coordination between two project teams because you have fixed release cycles, right? And that's what the kind of hindrance of this application architecture, which is legacy, and that was slowing business down. And that's why people were starting to ask about what we can do about it and how can we be more agile. So the genesis of modern architecture is, all the components are loosely coupled. You can make a choice of a technology for presentation layer. You can write it in Node.js, AngularJS, React.js, anything of your choice. At the server side, you can make use of containers. You can make use of serverless. You can make use of event bridge. You can have a different patterns of integrations in terms of request response, asynchronous integration, caching integration, queuing integration, and things like that. In modern applications, everything is loosely coupled, and all of that will talk to each other through APIs. So essentially, if I correlate, over the period of time, customers have developed that three-tier architecture, and let's call it as a monolith. And all the functionalities and the small cubes within the cubes are nothing but the functionalities within it. And these are not individually deployable components. This is the monolith, which has been developed over the period of time, which has a legacy, which has been implemented with the patterns or design patterns, things like singleton, right? Service lookup and things like that. When people started questioning about, how I make it modern, and then there is a buzzword around 10, 15 years back that there should be a microservice architecture, service-oriented architecture, which will be secure, which will be called through APIs. APIs will be on the HTTP endpoints. They need to be secured and things like that. But is it really that practical scenario that, the software which is written over a period of 20 years can be broken down into smaller APIs? Yes, some customers do that. That's an ambitious target, right? You have to invest in a lot of software developers. You have to invest in a lot of architects to break it down and have a project of 6 months or so to make it purely microservices. But not every customer can afford that, because every customer is of different size, different skill sets, and different budgets. So what people have done is that, is there a way that we can take a baby step towards modernizing it over the period of time? And what does that mean is that, within a big monolith, there will be logically clubbed applications, logical group of functionalities. Can I carve it out and put it as a containers? And that's where containers started coming in. Right? So containers are nothing but customers started looking at as the sub-modules of a functionality which can be can be deployed in isolated fashion. So that's the middle box. But is that really a microservice architecture? What is the principle of microservice architecture? Every microservice should be self-sufficient, should be accessible by API. It will have its own data source and things like that. But when we are trying to break this monolith into smaller pieces, can I really have an independent database for every microservice? Answer is no. So when we talk about the middle box, we'll have a bunch of application servers or bunch of microservices which are not really microservices because they are talking to the same database. Because when it comes to code changes in those two microservices, you have to take downtime because there is a common database. So the principle of microservices is, we have an independent business logic, we have independent database, we have independent notification engine and independent UI if it comes to that. That's a true microservice. And if you zoom out, how the microservice architecture will look like, every integration east or west, north or south will be through APIs, and APIs will be secured by identity and access management. So this is in principle that, legacy and the modern application, what are the principles. Now let's talk about, modernization. Change is the only constant, and then we have to do a change for us to keep pace with the technology and business. Agility is a need of a business, Can we really take a downtime of a website if you want to change a smaller function? No, we really cannot. So that was a need of an hour for customers to go after the modernization. And cloud helped customer a lot when it comes to migration and modernization. A lot of customers have taken their first step going to the cloud. So first question is in a different color because many of the customers have taken that first step and have gone through the challenges and are on the cloud. When on the cloud, customers ask a question that, how can I modernize? What are the tools? How life of my developers will be made easy? Because historically, developers have database on their desktop or laptop. They have their integrated development environment on their laptop or desktop. They are able to make code change right there, test it, and then put it over to CI/CD pipeline for the production deployment or a UAT deployment. But when it goes to cloud, can I have my database on my laptop? Answer is no. So developer will be in question mark that how can I do a development in fast fashion? So what are the tools, right? So what are the governance and security parameters for my developers, for my operations people, for my admins, and things like that. And when it comes to architect sitting for a re-architecting an application, containers, should I go ahead with containers or should I go ahead with serverless? And these are the kind of questions that we have seen. But why we are doing this? Because this is a lot of effort. It sounds like a lot of effort. But with the tools and technologies and the skills of cloud, it is not that difficult. But why do we need it? What are the business justification? Business will be more agile when it comes to deploying the new features to the cloud. They will increase the efficiency of their people, and overall it will be reduced total cost of ownership of your application. So these are the business benefits. Business will be happy. But when we talk about IT benefits, what are those? These are essentially non-functional requirements. None of us likes to go to a website and then page takes a lot of time to load. Right? Response time is important, latency is important. Many a times website will get famous and then it will scale from 10 users to millions of users. There needs to be, there is a need of scalability. Data is in GBs right now, but it could go to TBs, and there is an expansion of data as well. So modern applications should be resilient enough, to take care of all this. So when it comes to migration and modernization and customers are convinced, then typically there is a 7-hour approach for migration and modernization. I'm not going to talk about remaining 4 hours, but for modernization perspective, there are 3 hours which are relevant. First one is replatform. Many of you would have known that what is replatform, right? So when we conventionally do lift and shift of the cloud, the lift and shift from on-premise to the cloud, what we do is that we convert physical machine to virtual machine and put it on cloud. At the max, what we do is that look at the utilization parameters of CPU, memory, network, and right size the server, and then essentially put it as an infrastructure as a service. Will it give you any benefit? Yes, it would, but would it really give you true benefits of the cloud? Answer is no, because you will still have operational overheads. Your system administrators would still end up doing the patching of the server and upkeep of the servers and things like that. They also need to be worrying about high availability of the servers. So what is replatforming in context of database and in context of, let's say, applications, right? So instead of stitching your cluster of containers yourself, you can make use of the managed services. And this is not something new I'm talking about, but it really kind of takes away the overhead of you maintaining the cluster for containers. Similar is the case with database. Instead of you maintaining the database cluster, you can adopt the managed services of a database, then you can really get rid of operational overhead of maintaining a database. That's the replatform. When it comes to modernization, we recommend that you convert your application into containers wherever you are and then go to the cloud. It's not a hard and fast rule. If you can go to the cloud and do modernization, that's fine. But over the period of time, we have seen that you be comfortable with your application, carve out a container and then go to the cloud, because deploying a container in the cloud is simple. Second principle is refactor. This is really looking at someone has time and energy to do a re-architecture of the whole application. Break that monolith into smaller pieces, truly design grounds up architecture using cloud native capabilities of security, resilience, uptime, and response time and things like that. Here, serverless comes in handy because you are questioning every single layer. If you are going to do a refactor, then serverless makes sense because it will Raj will cover the benefits of serverless work over container, but it will really reduce the time of your execution, and you will get billed only for the time of the execution. So that's the refactor. It gives you efficiency. It gives you native integrations with a lot of AWS or cloud services, which will make your application future-proof as well. Third component is build new applications. Now, if you are a platform company and then you want to write software once and leverage it multiple times, I'm talking about converting your software into software as a service aspect. You can write a software as a service, you can stitch in billing and metering components to it, which are pre-built, and then it really becomes software as a service for your customers. That reduces your customer onboarding time, increases your go-to-market penetration because you are rolling out functions or functionality quicker and faster. So that's about building a new applications. So which are the technologies to help, right? So AWS has a philosophy of that we want to take care of undifferentiated heavy lifting of maintaining infrastructure. We don't want you guys to think about how to keep my servers running and how to keep my applications resilient. We want to take care of that for you. And for that, customers would have to think about how to write a piece of code which is more feature rich and more meaningful to customers. So that's the overall message. And then why to modernize with containers? Because by principle, containers are carved out operating system, dependencies, libraries, data sets together. So half the part of the job is done if you carve out a container image, right? And then it becomes easier for you to deploy it on the managed container service so that operational part is also taken care of. So which are the services that we have on offer? Not anything new here, but when you have multiple services, they need to talk to each other. There needs to be security. There needs to be access control. You have to have services to orchestrate that. So that's the app mesh. From the hosting standpoint, there is a ECS, that is Elastic Container Service by Amazon, and there is EKS, that is Elastic Kubernetes Service by Amazon. So these are two components. Now, a lot of time customers ask us that the two services, both of them are AWSs, both of them are compliant with Docker. Which one to choose and when, right? That is where we'll be more prescriptive when Raj is on stage. Underneath that, if I am running a container cluster, would you want to have control over the infrastructure or not? If you do, then there is an option in cloud that you can do that. But if you say that, I am really looking forward to abstract that thing, and I don't care whether how it is getting scaled and how the servers are getting split millisecond response time, then there is a Fargate. Because all that scaling and operational uptime things are taken care by Fargate. Again, there are two choices for you to make. And ECR is nothing but a standard container registry to register a Docker image and things like that. So I will not spend much time here. I think I have covered this. These are different options of services that we have, and Raj is also going to cover this. There are two services, as I said, Elastic Container Service by Amazon and Elastic Kubernetes Service. The general phenomenon or general mindset of customers are like, I don't want to leave the openness of a technology. Kubernetes works anywhere because it is open source. Yes, that is true. But Kubernetes clusters are complex to run. If you are running microservices which are hundreds and thousands of them, then yes, Kubernetes makes sense. You have to have those components, Zookeeper components and other components to upkeep of that. There is admin component and things like that. But those components are designed to meet certain needs of scale. But if you are a new adopter to containers, I know that I am going to have only 10 microservices, 100 instances. I have a standard Docker image. Then it is simple, straightforward container implementation. You did not have or need not have complexity of running a Kubernetes cluster because you have a straightforward requirement. And that is where ECS becomes very simplified definition of your container, of your Docker container deploying it on AWS. It's quite straightforward. And it is recommended for beginners who want to start their journey with containers to take care of the simplicity of the deployment and things like that. How architecture will look like? It will be similar to your architecture because the orange dotted box that you see will be taken care by AWS managed services. Either it is ECS or it is EKS. Now, this is an interesting topic. So, many times customers ask us that I want to write a container which will run on premise, which should run on cloud, which should run on any other cloud and things like that. And then people are saying that if I adopt to ECS, then will I restrict my capability to run my containers to other data centers or other on-premise setup? But if you think about it, ECS is nothing but hosting or orchestration layer which holds your Docker container. And you can run Docker containers anywhere. There is no issues with that. The slide I want to emphasize on this, the point I want to emphasize on this slide is that, now technology is evolving. Now modern architectures are not running out of data centers, not running out of AWS cloud or cloud, right? So now there are a lot of offerings specifically done by AWS in the last 2 to 3 years, things like AWS local zones. These are not AWS regions. These are the data centers close to your city, the local zones. AWS data center coming to you, near your city. AWS wavelength. These are the AWS components running within 5G towers or running within telcos offices for the edge computing and edge computing use cases and things like that. We have outpost. If you have a need of, I want AWS infrastructure running out of my data center, then you have AWS outpost, or you have your own data center. So there is a abstract component, we call them as ECS anywhere and EKS anywhere. So if you have those two components, you can not only run your ECS and EKS containers on AWS region and other AWS components, but you can run the same fashion and form in your data center as well. So that way, having ECS, you are not getting tied up to AWS because ECS anywhere solves that problem for you. Application is one layer, but there is another layer like data, right? So there are other services in terms of file service, object service, object storage service, file system service, the deep archive service. A lot of it comes as out of the box. They are not, even though they are part of the application modernization journey, but they are using serverless components some form or fashion. For the application standpoint, Lambda is the key. Lambda is a truly serverless component, and API gateway is the abstraction layer on top of Lambda you can integrate with and secure your APIs. So I will not spend much time here because Raj is going to cover it anyways. So for us, Lambda is the business logic that you run. You are not paying for any idle time, because if you are running it 10 times, you are going to charge only for 10 times in unit of milliseconds. It's pay as you go, pay as you use. It's highly available. It scales as per use. So how Lambda architecture looks like? Straightforward: API integration, business logic, and database. If you look back the zoom in slide that I showed earlier, this is encapsulation of a microservice. And that's why when someone want to refactor or start writing a new application from scratch, Lambda makes more sense, because by principle it is designed that way. So together and how, right? So there are two points I touched base upon, right? So containers and serverless, that is Lambda. So now we have come to the point that how they are going to benefit. So this slide is a little busy, but if you look at from the top to bottom to top, so bottom is a legacy. We have been running that as an infrastructure as a service, and then ECS, EKS is a platform services or managed services. When you climb up, AWS Fargate, it is serverless way of hosting your containers as well, and then at the top is a Lambda, right? So if you read the slide from the bottom to top, you as a customer, your responsibility get reduced, because undifferentiated heavy lifting is being done by AWS, and you will end up writing only piece of business logic when you are leveraging AWS Lambda. So with that, we come to the point that we want to make a choice. What are the pros and cons? If you are an architect, what are the points that you should think about whether to go for containers or whether to go for Lambda? What is the decision tree, right? That will help me take those decisions when you are on the whiteboard. So for that, I will invite my colleague Raj to take it further. I hope you find this insightful. Over to you, Raj.
Thanks, Mandar. It's always very interesting, right? When you hear about a topic from a speaker, you get to learn new things. So no matter how many times I've heard this, when I hear from somebody like Mandar speaking, you get to learn something new. So thanks a lot, Mandar. I actually got a couple of points there myself. Right? The question is, when do we start with microservices? Right? The answer is now. Right? In the sense that you have to think, are microservices right for you? Does the application architecture that you currently run on, for example, today morning I was talking on a DevOps session, and a lot of questions came up. When do we choose? For example, they have a longer DevOps cycle. That's probably one of the reasons why they might be better thinking of microservice architecture, because it's a monolith. Right? They need to break it up so that their DevOps cycles become much better. Right? So I'll not waste a lot of time there. So like Mandar talked about, right? If you look at a microservice, essentially a microservice is a combination of three core components. One is an API layer, another is a function layer, and the database that's in the backend. Right? Databases generally are centralized, but in a true microservices world, even the databases are abstracted out to match a particular microservice, so that they can grow in that sense. Right? Right. So what are the considerations that we have to choose one over the other? We choose containers if, for example, again, these differences are becoming less and less. Right? Lambda as a serverless technology is evolving on a daily basis. Now there's literally innumerable choices of the underlying environments that you can run on. Right? In the olden days, Java, Python, or a few set of technologies were available for Lambda to build microservices on. That's basically where containers made a lot of sense. Right? You have better control when you're running containers. For example, one of the challenges Lambda has is the timeline. We can't run more than 15 minutes. Right? I mean, you can overcome that with something like step functions, which is also part of the serverless technologies to overcome that. But containers can make that choice better for you. So going on, the other considerations that we can think about, right? Because in serverless Lambda, for example, you give it a memory and CPU is accordingly allocated, and you pretty much play around with what is the best suited combination for you. But with containers, you have a choice. You can choose EC2s like Mandar mentioned before, right? You can choose any set of EC2 combinations to run your microservice on. Right? And most importantly, one of the things that you can think of, for example, one of the core things about microservices is that polyglot. Right? You should be able to develop your microservices in any language that you can think of. You can solve multiple problems in one single language where you try to think about a workaround. For example, machine learning problems. If I have to think about machine learning, the default language that comes to my mind is Python. Right? So microservices encourage polyglot developments. That's exactly where I think you can choose Lambda as a platform where you could run different technologies to build those functions and then have them run in that fashion. So how do you choose? I mean, I think this is already talked about by Mandar quite a bit. But how do we choose between containers and Lambda or serverless technologies? Is basically if you have a low latency requirements for your applications. Again, low latency is very relative because it could be possible that Lambdas they remain warm, and if you define the Lambdas properly, like global variables and all that stuff, there could be no issues with latency itself. But again, depending upon latency, again being relative, you choose one over the other. And similarly, if you require longer running times, which is for example more than 15 minutes, then you choose containers. Otherwise, you can choose Lambda. And again, you can overcome that challenge also depending upon how your application runs by using some orchestration of a layer like step functions. And again, the control of environment. If you want a full control of the environment, access to the underlying infrastructure, the control plane, you are better off with containers versus Lambda, which is entirely fully managed for you. All you do is bring your code, and you pretty much can run at scale. Right. So yeah, I think I'll skip this one. We already talked about this. So let's look at a decision tree. Well, it's almost a decision tree. It's not entirely a foolproof guide to choosing one over the other. But let's say, like I said, the difference between Lambda, serverless, and containers is reducing as Lambda is more evolving. Right? Let's say if your choice of technology or what you build on is limited to well-known technologies like Java, Python, .NET, and if the answer for that for you is yes, and if your deployment code size is less than 50 MB. Right? That's one major thing to keep in mind when you choose containers and versus Lambda. And if the answer for that is yes, and if your desired or the time it takes to complete a function is less than 15 minutes, not exactly 15 minutes, but with a good buffer to 15 minutes, and the answer for that is yes. And if your demand is unknown, for example, if if you don't know how your functions are going to be executed, and you pretty much have the functions running in isolation. You don't have multiple functions communicating with each other, and if you don't have such a dependency, then then you choose Lambda. Sorry, we didn't pray to the demo gods before coming to the stage. So this has to happen, right? If the answer for any of the questions that you have was no, that's basically when the choice for containers become obvious, right? Again, like Mandar had shared, there are several options for containers today, right? You could choose ECS, you could choose EKS if you're more open source. If you choose, you could choose Fargate. Again, Fargate gives you the flavor of both a serverless environment with containers that you run. And just for the sake of you can even run a container image with Lambda currently. That's the kind of changes Lambda is evolving into, right? If you desire full orchestration or you require a lot of control in your environment, that's basically where you would use Amazon EKS. If not, if you are again, if you need to control your your environment. That's basically where you would choose either ECS or Fargate. Again, Fargate is fully managed environment to run containers, where you simply say, hey, I want to run this container, this image for in a specified manner, and it just runs it for you. Right. So what exactly does serverless mean in our terms? Right. Serverless essentially is not having to have any VMs, any machines running. It's entirely managed environment where you simply bring in your code, right? And the requests and the environment or the Lambda function scale for the number of requests that come in. We usually talk about Lambda when it is serverless, but it's not just Lambda, right? We have many other serverless services. For example, if you look at from a compute standpoint, yes, Lambda makes a lot of sense there. But for example, if you have data sources to look at, we have Amazon S3. It's been there forever. Amazon S3, how it started as a basic object store and finding itself as a center of data lake architectures today. It has evolved, in a big way. And one of the reasons for that is that it's entirely, serverless, as a storage service. And we have Amazon Aurora as serverless, DynamoDB, and from an integration standpoint, all these services. For example, Amazon SQS, it's a JMS compliant queuing service, SNS, step functions like I talked about as a the orchestration layer for Lambda, and so on and so forth. Right. So the question is, yes, I know I need to go into microservices. Now, do I have to do it with containers or serverless? Can I not do both together? This is usually a challenge that most of us face. Well, the good news is, no, you don't have to. It is a combination of both. Right? You can evolve to microservices. You can evolve to serverless while running in containers. Like I said, if you look at a microservice, it's usually a combination of APIs, functions, and the database in the backend. If you can think about it in that sense, then you can easily choose one over the other. Right? So that's basically what this is. So you have an API gateway in the front, which essentially is routing traffic to both your container-based in a backend and or on the fully managed AWS environment. So let us look at some of the architectures. In the interest of time, what I'll try to do is talk about what we can do. For example, let's say if you, I'll pick up an interesting use case. For example, you want to expose. Let's say you're running your microservices both on cloud and on your premises, for example, right? And it doesn't have to be on premises, even if it's in AWS. You're running in a fully managed or self-managed container environment. And how do you expose both these services? So you just put an API gateway in front as a facade, and then use a network load balancer, and then route traffic to both these services. It's pretty straightforward. And this one, for example, like GraphQL. How many people have heard of the term GraphQL? Right? It's one of the most common mechanisms to expose data APIs to your front-end applications. Right? And AWS has introduced a service called AppSync. It's a serverless service that actually gives you a fully managed GraphQL endpoint, GraphQL environment, right? And just simply use the resolvers, no matter where these services are running, right? If you're running, your containers on premises or on cloud, you can pretty much have a resolver for that, and then expose these APIs, right? Just bringing the APIs into API gateway and all those serverless services, right? Let me go to this one, backend batch processing. This is probably basic, a scenario where it might be a hard choice to make, either go with containers or go with serverless, because like we said, sometimes you might have batch jobs which run longer. Sometimes you have batch jobs which require legacy, applications which cannot be easily ported to Lambda and things like that. Right? In such scenarios, right, you could pretty much have, use some of the serverless services and a combination of your container images to process those backend jobs, and use SQS as a message layer to process the messages, or S3 if there are any objects that you need to process as part of the batch job, pretty much do that. But an interesting mix to that is use Lambda, where your batch batch job meets those core requirements, less than 50 MB in size, less than 15 minutes of execution time, what you could do is, Lambda is so well integrated with some of the AWS services. If I am integrating Lambda with SQS, a message that I'm processing is temporarily not visible for other functions, so that once I process it and I process the message properly and return successfully, that's when the message gets automatically removed from there. If I somehow fail and make sure that this message is not processed by me and error out, it appears back in the queue without you doing anything. That's a very big work, if you ask me, right? How do you manage the queue? So with Lambda and SQS integration, that's pretty much, built out of the box. That's one interesting use case where you could leverage Lambda, if you think about it. And let's look at this one. I'm already out of time. Just give me 2 more minutes, and I'll try to close this. All right. If you have existing APIs that you want to expose to maybe, let's say, to external vendors, customers, and they want to use your APIs for their processing, right? How do you do that today? You simply put an AWS API gateway. AWS API gateway comes with a lot of features that come bundled in. For example, let's say if your APIs that have been built internally probably did not have a requirement of authentication, for example, because they're running internal. Anybody who had access to these could pretty much execute them. Or there was no requirement of caching and stuff like that. So with putting API gateway in the middle, you can enable authentication with any of the either federated authentication or some of the open standards. You can enable that, and you can also enable caching and without having to touch any of your existing microservices. Similarly, you can extend it further by throttling, right? Let's say if you have built your microservices in your premises, or which are pretty much limited in capacity, you could actually throttle them just by configuring something on API gateway. Say I don't want to allow more than X number of messages or requests to be processed in a given amount of time, and API gateway automatically takes care of that for you. Right? All these features come built in by just putting API gateway in front of your backend microservices. Right? That's something I wanted to show you guys. We have a few more, but I'll just pause here. Thank you so much for your time, and I'll just go forward. This is a very interesting quote by Jeff Bezos. Right? Everything, when he says every new thing creates two new questions and 2 new opportunities. In my opinion, containers have actually done that. Containers originally solved DevOps problems, but now they also are solving microservices problems, which are helping us scale to global size applications. So with that, I want to take a pause. Thank you so much, and here is the here's a slide for if you want to find more information about learning. Thank you so much. Thanks.